In this video, we're going to examine solving problems when force is applied at an angle. Let's look at our problem for today. During COVID lockdown, Gracie Nelson decided to take her kitty cat Civvy for a walk in the baby doll stroller. Gracie pushed the stroller at an angle of 30 degrees above the horizontal with a force of 3.2 newtons. The cat and stroller have a combined mass of 2.8 kilograms. What is the normal force? What is the net force of the system? How fast does the cat stroller system accelerate along the frictionless hallway? As you can see, we're solving for multiple things: the normal force, the net force, and the acceleration. The first step to solving all of these problems is to create a free body diagram. So let's go ahead and get started. So I'm going to start by drawing the stroller cat system as a box. All right? And then I'm going to start drawing my forces. My first force that I always draw is my force of gravity. I'm going to label that F of G. Then we know that the cat stroller system is sitting on the floor. So there's going to be a normal force normal. Okay? And then there's an applied force here, okay, that is happening at 30 degrees to the horizontal. Okay? That pushing force, all right, can be resolved into two different forces. So if I draw it over here, I have my force applied that Gracie is applying. That has a downward component, and that has a component that goes to the right. So I'm actually going to draw this as two different points. I'm going to draw it as an x component. So I'm going to call that force applied in the x. And then I'm also going to apply the downward component as force applied in the y. Okay? Now I haven't assigned values to any of these, and we'll talk a little bit more about how we would find the net force. But let's look here. All right? So how would we find the normal force? All right? I want you to stop here and pause the video and see if you can write an equation for solving for the normal force. So go ahead and pause. All right, have you had a second to write the equation for the normal force? So the cat stroller system is accelerating down the frictionless hallway. It's not going up or down. So because it's not accelerating up and not accelerating down, the net force in the y direction must be 0. So F net in the y direction must equal 0. So what are the forces in the y direction? So we have the force applied in the y direction plus the force of gravity in the y direction plus the force normal, and all of those must add up to equal 0. Well, we know force of gravity, F of G, equals mass times gravity, and we can solve for the force applied in the y direction. All right? So, for force applied in the y direction, we're going to have to use our SOHCAHTOA. SOHCAHTOA. All right. So let's look at that. I want to find the y direction, that is this arrow here. I know my angle here is 30 degrees. That is my opposite of my angle, so I'm going to use sine. And I know my applied force is given to me in the problem. My applied force is 3.2. So my force applied in the y is going to be 3.2 newtons times the sine of 30 degrees. Okay, that's my force applied in the y. Then I know my force of gravity is going to be my mass. My mass of the system is 2.8 kilograms. And I'm going to multiply that by the acceleration due to gravity, 9.8 meters per second squared. Then we have force normal. We don't know what force normal is, but we know that all three of these have to add up to 0. So first I'm going to find that force applied in the y, looking at this 3.2 newtons times the sine of 30. That's going to give me my force applied in the y. So I want you to go ahead and put 3.2 sine of 30 into your calculator. And once you've put that into your calculator, you're going to find that that is 1.6 newtons. That is the force that is applied solely in the y direction down. Okay? All right. Then we need to solve for the force of gravity. We're going to take the mass, okay, and multiply it by the acceleration due to gravity. So let's go ahead and take a second to put that in your calculator. All right, and I get 27.44 newtons for that. All right, and that's more sig figs than I'm going to need, but we're not going to worry about that. Plus the force normal, okay, equals 0. Now I want to think about signs here. All right, right now I've kept my signs for down as positive and my sign for, that means my sign for up for force normal would be negative. But usually we make our downs negative. So really my force applied in the y should be negative, and my force of gravity should also be negative because it's negative 9.8 meters per second squared. So just make sure to double check that you are paying attention because these are vectors and we need our vectors to go in the correct direction. So when I solve for this, force net, force normal, is going to equal negative 29 newtons, or approximately, it's 29.04. So 29 newtons in the normal direction. All right, so we found our F net in the y. I want you to take a second to find the F net in the x. F net in the x direction. So take a second, pause the video, and see if you can figure out the F net in the x direction. So the net force in the x direction is going to equal the force applied in the x direction. So it's only one force. All right, so how are we going to solve for our applied force? Well, we're going to have to go back to our original force applied equation and use SOHCAHTOA again. For the y component, we used sine. So when we were finding this, we did 3.2 sine of 30. Here, we are now adjacent, okay, adjacent, all right, and adjacent is cosine. So to find f of x, F applied in the x direction, we're going to be doing 3.2, and instead of sine, we're going to do cosine of 30. Okay? And that's going to give us a value of 2.77 newtons. All right? Now let's think about the sign that's going to go on this. All right? This is, she's pushing this. When she pushes this, the push force is down and to the right, right? We generally say the right is positive, so I'm going to leave this force as positive. Whereas when I had the force applied in the y, I made that negative because that was a downward force. So think critically about what is the sign going to be on your force, especially when we're at an angle. So this is going to be a positive force, okay? And that force is going to be 2.77 newtons. All right, and that ultimately is the net force of the whole system, okay? Because we've already determined that the net in the y is going to be 0 because the cat's not going up or down, the stroller's not going up or down. All right, so let's go. We found our F net, so that's going to equal our F net. Okay, we've got our net force. Now, we need to figure out how fast the kitty stroller system accelerates down the hallway. Well, we've recently learned a new equation. Force equals mass times acceleration, right? We know the force that is ultimately being applied, the net force being applied to the system. So now I can find how fast the kitty stroller system is going to accelerate. So knowing that my force, my net force is 2.77 newtons, And I know the mass of my stroller system. That's 2.8 kilograms. Now I can find my acceleration. So go ahead and take a second and see if you can figure out what the acceleration is. All right. This one should be relatively not surprising, but our acceleration is 0.99 meters per second squared. So she's going to be accelerating about 1 meters per second squared on the frictionless hallway. I hope this lesson was helpful, and if you need extra help, be sure to reach out. Thank you. Bye.